What if I told you that the entire universe, the galaxies, stars, planets, and everything you know, might actually exist inside a black hole? Sounds like science fiction, right? But this idea isn't just a wild theory from the edge of the internet. It's a real, serious hypothesis that some physicists are exploring. And when you start diving into the numbers, the structure of space-time, and the way gravity bends reality, things start to line up in the weirdest ways. In this video, we're going to break down how this theory works, what evidence supports it, and what it would actually mean if we were living inside a cosmic monster. Let's dive into the rabbit hole, literally. What is a black hole really? Before we start imagining ourselves inside one, let's get clear on what a black hole actually is. At its core, a black hole is a region of space where gravity is so intense that nothing, not even light, can escape. Every path through space and time curves inward, meaning once you cross the black hole's boundary, there's no turning back. This boundary is what physicists call the event horizon. Think of it like a point of no return. But here's where things get even weirder. The more mass a black hole has, the bigger its event horizon becomes. If you double the mass, the size doubles. Multiply the mass by 10, and you've got a black hole 10 times the diameter. It's actually a linear relationship. So now ask yourself this. If we calculated the mass of the entire universe and ran the black hole math on it, what would we get? Shockingly, we get a size almost identical to the size of the observable universe. Could that be a coincidence, or is it a clue? The universe's horizon versus a black hole's edge. Here's where things start getting spooky. Just like a black hole has an event horizon, a boundary beyond which no information can return, the universe has its own kind of horizon. It's not caused by gravity trapping light, but by time itself. Our universe is only about 13.8 billion years old. That means light from anything farther than 13.8 billion light years away hasn't had time to reach us yet. That's our cosmic horizon, the furthest edge of the observable universe. And here's the eerie part. When you calculate the average density of all the matter inside that cosmic bubble and plug it into Einstein's equations, you get numbers that match up with a black hole of that size. In other words, from the inside, our universe could look exactly like the interior of a black hole. It's not proof, but it's weirdly consistent. So, what would it mean if we were living inside a black hole? Einstein's theory and the other side of a black hole. According to Einstein's general theory of relativity, black holes aren't just one-way traps. Mathematically, if you go beyond the event horizon, it's possible for an entirely new space-time region to exist on the other side. Think of it like this. From your perspective, falling into a black hole, time keeps moving forward, but what's behind you starts speeding up until you see the entire history of the universe flash by in reverse. Meanwhile, a whole new universe could be unfolding ahead of you. It's a bit like going through a one-way door into a different reality. Some theoretical physicists suggest that every black hole might contain a new universe on the inside, and our universe could be one of them. That means the Big Bang wasn't the beginning of everything, but rather the start of a new timeline, inside a much larger cosmic structure. A black hole in another universe could have birthed ours. We could be living in the aftermath of someone else's collapse. Section 4. The strange clue in galactic rotation. Now let's shift gears. A recent study observed something unexpected, something that doesn't line up with the idea that everything in the universe is random and uncoordinated. Scientists looked at several hundred spiral galaxies from the best vantage points, above and below the plane of the Milky Way. What they found could change everything. They noticed that 2/3 of these spiral galaxies were rotating in the opposite direction of the Milky Way. That's not what we expect. In a random universe, you'd think half would spin one way and half the other. It should be like flipping a coin. But this suggests a net rotation, a kind of cosmic spin across the entire universe. Where is that spin coming from? Could it be a leftover signal from something bigger? This is where it gets juicy. The physics of spin. From gas clouds to galaxies. To understand why this is such a big deal, let's break down how objects in space start spinning in the first place. Imagine a huge gas cloud in space, big, cold, and barely moving. As gravity pulls it inward, even the tiniest bit of initial motion gets amplified. This is known as the conservation of angular momentum. You've seen this with ice skaters. When they pull their arms in during a spin, they rotate faster. Same principle. In space, when that giant gas cloud collapses to form a star or a galaxy, it starts spinning faster and faster. That's why nearly everything in the universe, planets, stars, galaxies, has some kind of spin. But here's the kicker. Each gas cloud starts with random motion, so we expect their spin directions to be random too. In theory, one galaxy spinning clockwise has nothing to do with another spinning counterclockwise. There's no reason their spins should line up, unless there's something linking them. Which brings us back to the big question. Why a spinning universe points to a black hole? If galaxies are spinning in the same direction more often than not, that tells us there might be a net angular momentum in the entire universe. And in black hole physics, that's one of the only things that survives when something falls in. Here's how it works. When an object spirals into a black hole, its mass and spin, its angular momentum, get absorbed. Everything else gets lost. So if the black hole that created our universe had a spin, we would inherit that spin. And that could explain why galaxies seem to be rotating in the same general direction. This is what ties everything together. The alignment of galaxy rotation, the shape and size of the universe, the behavior of black holes, all of it might be pointing to one cosmic origin, a parent universe that collapsed and birthed ours. Could the Big Bang just be the other side of a black hole? Big Bang or Big Bounce? Let's stretch the imagination a little further. Most of us grew up learning that the universe began with the Big Bang, a mysterious explosion from nothing. But if we're living inside a black hole, maybe that bang wasn't the beginning. Maybe it was the bounce, the result of a collapsing star or even an entire universe in another dimension. In this view, universes don't just begin and end. They cycle. One dies, collapses into a black hole, and on the other side, a new one is born, ours perhaps. This concept is sometimes called the cosmic bounce theory, and it solves a few nagging problems with traditional Big Bang cosmology, like where all the matter came from and why the universe is so uniform. Now, this isn't proven, it's still theoretical, but it offers a powerful narrative, the universe as a continuation of something greater, rather than a lone miracle. So, are we inside a black hole? Let's bring it all together. The size of the universe matches what a black hole would be if it contained this much mass. The galaxies? They're spinning in a way that suggests a cosmic angular momentum, one of the few traits preserved inside a black hole. Einstein's equations? They allow for entire universes to exist beyond the event horizon. So are we definitely living in a black hole? Not necessarily. The data isn't conclusive yet. The study that observed galaxy rotation only looked at a few hundred galaxies, and we know there are billions out there. Until more research is done, we can't say for sure. But if future observations confirm this spin, it'll force us to rethink everything. The universe wouldn't just be expanding, it would be spinning, spiraling, and maybe even rebirthing itself. And so are mystery in the stars. Science doesn't always give us neat answers. Sometimes it gives us better things, questions that shake our understanding of reality. Whether or not we're in a black hole, this theory challenges us to think bigger, to imagine beyond what we can see. And that's the spirit of discovery. So next time you look up at the stars, ask yourself, are we looking outward or inward, into the heart of something far more mysterious? Until next time, keep looking up.